All right, here's our video today, Algebra 2, and we're talking about the period and frequency on the sine graph. And we'll also talk about the sine wave, right? We should know about the sine wave before we talk about the period and the frequency. Well, you can see in the back of the title, you see that blue line? No, that's a sine wave. Let's get a better picture of it, though. Let's draw one. But before that, let me make sure we write the definition for you. So a sine wave that we put on the graph, so we'll say a sine wave, and that's what it's doing. It's waving. Sine wave, it's going to go through periodic, and when you see periodic, the word periodic, it just means it's going to repeat. So it's going to repeat. Periodic, and here's a fancy word, oscillations. And oscillations means is that they wave back and forth. So a sine wave, like when you wave, you're waving back and forth, up and down. So you can see the sine wave, and I'll get a better picture for you, but it's going up in the blue line, it's going down and back up, and it's going to repeat itself. All right, here's our bright red screen, and we'll use yellow. Why not? So I'll make and when we think about a period, though, again, so remember, a period will, if you think about in high school, every, depending on your high school, sometimes every 40 minutes is a new period. Some high schools have 55 minutes. So in high school, every 45 minutes, you create a new period. It's repeating. And you think about in like the seasons, like we start the year in winter, January 1st, we're in winter. Then we go to spring, see the cherry blossoms. Then we have our summer vacation, some people, right? And then we go into autumn or fall. And guess what? We repeat. So it's periodic. So we know what periods are. It just keeps repeating. Just like a clock, right? We have our clock, which we'll kind of use in a minute. We're going to use a unit circle. So the clock goes from 12 and 3 and 6 and 9, and then the numbers repeat. It's a cycle. And so when you hear period, you'll also hear cycle. They're the same thing. So let's clear that out. Let's get a sine wave going. And I'll make my x and y. There's my y, there's my x. And here's my sine wave. So I start here, and I'm going up, right? I'm reaching the peak, the max, coming down. So right, it's like a parabola. And we're going down again and up. So, and this repeats. We're going to keep making sine waves. So where it starts, right here in white, where it starts, we'll put the start. And where it starts again. So it's starting again because it's going up again right there. Here it's going up. See the arrow? It's going up. Now it's going down, it's going up, hits the line, and it's going to go up again to make another sine wave. So from this point where it starts, all the way to where it starts again is the period, or the cycle. So that's what a period is. And the height of the sine wave, with that dotted line there, the height of the sine wave will be its amplitude. I'll put a little arrow. The amplitude is the height. All right, so let me draw a unit circle here. And so when we do a unit circle, we're going to show how this movement is done from this unit circle onto the graph. And you know when we're doing a unit circle, when we make angles, the angles go counterclockwise. Angles go counterclockwise. That looks like a G instead of an arrow. Let's make a better circle. Let me get you a better circle. All right, here's our giant circle. Use green. So again, on a unit circle, and we'll make a line coming down here. We have our unit, and the angles are going counterclockwise, right? That's what I was trying to make, not a G. Let's make an arrow coming through. So as we move up from right here, it'll be the start. So that's like the sine graph. So we'll make a little small sine graph over here. That's the start. And as this goes up, it's going up, reaches the top, the max here. Well, that's what it's doing on the sine. It's reaching the max. So on the unit circle, and we know the degrees would be 90 degrees. But we're not using degrees on the sine wave. We're using radians. We're using radians. So 90 degrees would be pi over 2. So there we have the 90 degrees. And you can see now we're going down on the unit circle. See, I'm going down. There's the arrow. So we'll go down here and we'll have our half of our sine wave. Right? And right over here, we know that's 180 degrees, but in radians, we know that's pi. So as you can see from the circle, as we go up, we're representing the sine wave on this circle. And it's going down again. And that's what would happen here. Let's change the color for the sine. See how it's going down? And then it goes up. See how it goes up all the way back to start. And it goes up all the way to start. And that's the first period. The first period where it starts and where it's going to start all over to create another sine wave. Again, remember, that's the period or the cycle. Now, if you see this pi here, pi radians is half waypoint. So at 360 degrees, when it starts over, it's 2 pi. So pi, so I'll show you that on a picture. Here we have the cycle. And we'll use purple. So here's the start right here. You can see it went up, it went down, and it starts again at 2 pi. There's 2 pi. So again, on the circle we created, as we were going from the start here, as we went up, we went down to pi, we went up, down to pi, just like we're doing on the circle. We went down, and then up again, down, and up again, and we reached back to start, or 2 pi. Now, the other thing we should talk about is frequency. So we talked about what a period is. We know what amplitude is. Remember, what's amplitude? It's the height, right? So right from there all the way to the crest, that's the height, that's the amplitude. So the frequency is the amount of periods in 1 second. How many periods do you get in 1 second? Or how many cycles? And we use hertz from a man's name who, guess what his last name was? Hertz. So we use hertz. So for example, 1,000 hertz would mean that the wave is producing 1,000 periods or 1,000 cycles in 1 second. So let's get a clean page again. All right. So now we see a sine wave. And let's use purple. Here's the start. We said as it went up on the circle, this was 90 degrees, which is pi over 2, or half pi, same thing. It came down to 180 degrees, which is pi. It went down all the way back up to 360 and starts over 2 pi. This is 1 cycle. 1 cycle, or 1, guess what? Period. You got it. 1 period. So let's say that this cycle is repeating 20 times per second. If it's repeating 20 times per second, well, we know that's 20 what? What did I say? Who remembers? 20 hertz. So the frequency is 20 hertz. The frequency is how many times is it happening? How many times? How many cycles? That's the frequency. In this case, it's 20 hertz. Now, if you had something that was 20 hertz, you want to know, well, how many seconds is the period? What do you think the period would be if you're having 20 periods in 1 second? Well, the time of the period would be 1/20th of a second. What if I said that, let's say, the frequency was 50 times per second? So it's going from start all the way from start to pi to 2 pi radians 50 times per second. 50 periods per second, 50 cycles per second. Well, we know that's 50 hertz. And the length of the period then would be 1/50th of a second. 1/50th of a second. All right, so just to review, remember a sine wave is a wave that oscillates, that's going up and it's going down, and it's periodic. It's going to repeat. And sine waves do appear in nature. I talked about earlier that they appear on the electromagnetic spectrum. So, the electromagnetic spectrum, we have radio waves, which are the longest waves. We have microwaves. This is all light, by the way. Radio waves are light. We just don't see microwaves or radio waves or infrared. Snakes see in infrared. Then we have visible light, VL, just we see, UV, ultraviolet radiation, X rays, and of course, gamma. And all these are light, and all these will produce sine waves. And radio waves are the longest, and gamma is the shortest. So, just one more question. If this is repeating itself 4,000 times per second, what are the hertz? What's the hertz 4,000 times per second? 4,000 times per second is 4,000 hertz. 4,000 times per second means, and what is the length of time for the period? Be 1/4,000th of a second. That'll be the length of the period. All right, so that is period and frequency and amplitude, let's not forget, on the sine graph.